Hi, thank you for joining us on leveraging GitLab CICD to certify your application portfolio to run on ARM. I'm Pete Goldberg, Director of Alliances at GitLab. Joining me today is William Arias, our Technical Marketing Manager, who's going to get a little bit more in depth. On today's agenda, we're going to talk a little bit about who GitLab is, GitLab ARM and AWS's Graviton2, and then the demonstration of managing the migration of your application portfolio to ARM-based instances. So if you're unfamiliar with GitLab, GitLab was incorporated in 2014. Today, we are 1,300 employees that are spread across 68 countries. We were remote before remote became a thing this year. Today, our adoption is very broad. We have over 100,000 organizations using us with millions of users. And 70% of the self-managed customers who store Git source code repositories in Git are using GitLab. We have a very strong open source model with over 2,500 code contributors. And since the inception of the project, we've had over 10,000 contributors. If you take a quick look, you can see we've grown at a pretty good clip over the last 5 or 6 years, and we expect to continue doing so in the future. Why would you choose GitLab? Well, one of the things about GitLab we're going to focus on today is that we're a complete DevOps platform delivered as a single application. And that's basically starting with out of the multiple stages of DevOps tooling with source code management and CI in a single application. Doing that gives you built-in security and compliance, end-to-end visibility and insight into your applications and how they deploy. It allows you to deploy software anywhere, whether that's in your on-premise data centers or in the cloud or to other types of devices. GitLab comes and can be hosted either by within your own environment, or we do deliver it as a SaaS platform. Our goal is to provide you with rapid innovation, and we believe in that because we use GitLab for ourselves to put out GitLab. And what you'll see is on the 22nd of every month, GitLab puts out a new release. We've been doing that for many years now. And again, we're open source based. Everyone can contribute, and we believe in a very collaborative and transparent customer experience. If you go online, you can take a look at GitLab, and you'll find that we are probably more public than you could ever imagine in how we do things within our handbook or throughout our website. We help you measure results, and we really look to the value we bring to our customers is increasing operational efficiency, which can be things like total cost of ownership, cycle time, deployment frequency, developers turnover, and employee satisfaction. So we make your teams work better together. Doing so allows you to deliver better products faster. And while you're doing that, be able to reduce the risks and security compliances that are out there, which is super important because if we're delivering faster, we want it to be more secure for everyone. To take a step back and talk a little bit about the platform and about how we talk about it being a complete DevOps platform within a single application, first, we're breaking the DevOps lifecycle into 10 stages from manage, plan, create, verify, package, secure, release, configure, and monitor, and defend. And what we're doing is providing all of this different tooling that people used to purchase as individual packages and putting them into a single tool. That allows your teams to have a single conversation, look at all the data across the different stages within a single different data store, use a single permission model, have all work in a single interface, and it allows your teams to collaborate like they've never collaborated before. And that is the real power of GitLab. There is no context switching. There's no remembering how to use different products. So again, it's how do we put this into a single platform so your teams can move faster. When we take that and we break down the life cycle and how we recommend our opinionated view of DevOps, what we talk about is starting with a business requirement coming out, and we create what we refer to as an issue. A developer can then take that issue and create a merge request with the changes in the code or whatever they want to do. And when they commit that code, that is when our CI pipelines and application security scans can start running. This is where we can put that all in the automated motion so that when those tests are complete, we can actually pop up a review app so you can see what it actually looks like, because some things you can make it through a unit test, but maybe they don't position on the screen correctly. At that point, we allow for peer review and discussions to happen within that merge request so that people can work asynchronously. They don't have to be in the same place, but we can have an ongoing documented conversation about what's happening. Once all of that has been approved, then we can then kick off our CD pipelines, which are going to allow us to generate and build that and deploy it to any of your infrastructure, whether that's cloud or on-prem. Our goal is to provide a first-class experience no matter where you deploy, whether that be VMware, AWS, Google Cloud, Cloud BC, wherever you want to deploy to. And then the final portion of that is being able to monitor so we can provide feedback and then generate new requirements. And that's sort of the premise of how all of GitLab works. When we get to William's portion today, he's going to talk a lot more of this, and you'll actually see how that user experience happens. Now, if you were paying attention back in May, Amazon launched these new AWS Graviton2 instances. They became GA. They were actually announced the year before at reInvent. And what we see is that ARM has become mainstream with AWS doing this. There's a huge price performance improvement that customers will start seeing. And what we expect next is, because there's big savings to be had, is how do we start thinking about what workloads you have in your portfolio that can take advantage of this and be migrated to ARM-based instances. And really the purpose of today's demo was to kind of walk us through the following scenario. So when we go into this and William talks about it, I want you to think about whether your organization has tens, hundreds, or thousands of applications. How do you start determining which ones you can migrate easily? Which ones, do they work as is, or do we need to do some level of refactoring? Because some applications will work pretty easily based on the type of programming language they use and some of the other external dependencies. Others are going to require minimal work. And then the other one is going to be which ones are going to take a lot more refactoring in terms of resources, and we're going to have to put a little more investment in. Because as an organization, you're going to want to figure out which ones you can prioritize so that you can move those quickly and then be able to have processes to go through the other applications in your portfolio to be able to manage that process. And so we're going to kick that off, and I'm going to have William talk a little bit more on how you can do this in one example.
Hello, my name is William. Let's deep dive today in how GitLab can be at the center of a program to test applications and create a process-driven migration plan from x86 to ARM architecture. So here is depicted what we want to do. We want to use GitLab and run a project called ARM Validator to start or trigger a multi-project pipeline. What this will do is that we have this group of enterprise applications, and they will use a runner based on ARM using AWS Graviton2 instance, and all of these projects will start building. And at the end of the day, what we will get is which one of them built successful under ARM and which one of them didn't. This will give us a high-level overview of how we can have a process-driven and systematic way of testing to migrate our applications from x86 to ARM. So let's assume we work in this company and we have created a group, or we have a group with several projects, a different portfolio, each one of these applications with its respective source code. And what we want to do is that in this migration or testing process, we want to know if these projects will be able to run under ARM architecture. For example, here we have a Spring app in charge of tracking expenses. So going back to our group, we want to know if these projects will be able to run under ARM architecture. So here under settings in CICD, we can see that for this group, we can register a specific runner. A runner is a project, open source project in GitLab that will allow me to run different types of jobs, like building, testing, and deploy. And for this task, for this challenge, the runner that we will use to build the project is using Graviton2 AWS ARM architecture. Among all the applications or projects we have here, there is this one that is very important, that is called the ARM Validator one. what we want to do with this project is that we will trigger a multi-project pipeline. What it means is that if you observe the GitLab CI YAML file, what we want to do is that once we trigger this project, we will start calling all the different projects or applications that reside within the same group. And all of these applications will start building, and they will use the Graviton2 ARM-based instance. So at the end of the day, once we run all of these projects and we test if they can build, compile, or run, or be deployed on ARM instance, we will get as a result a report telling us how many of them succeeded or failed. So if we want to take a look to this in a more graphical way, we can come here to CICD and let's observe how a typical pipeline that was already executed in this project looks like. So this is the visual representation of what was in the GitLab YAML file, CI YAML file. So what we can see here is that we start running this project, we test that everything is in place, and then we call all the other projects that they reside within the same group. And once we start calling them, what we have here is the concept of the multi-project pipeline. There will be a downstream job that what it's going to do is that each of the projects that reside in a group will start building. And for example, if this is green, it means that this ticketing system written in Java passed all our tests and was able to build and run on their Graviton2 ARM-based instance. And let's take a not so happy path. For example, this .NET application. What we can see here is that this one failed. So at the end of the day, what I will do with this is that this will bring my attention to find out what happened. I have 10 applications from where 4 of them didn't build on ARM. So this will give me a hint of where and how can I start debugging or refactoring or fixing the problem of why I couldn't migrate or run on the ARM instance. So let's take a look at different examples. So let's see a happy path. So this is Spring application. So here we have this Spring application, and let's double click on here and see what happened. So I can see the result of the job. In this Spring application for core payments, we can see that the runner that we were using to build this project was the Graviton2 based on ARM. We have the log, all the steps that it was running. We can see that there were some tests associated with it, that the tests were successful and that everything was okay. So if we double click in the pipeline of this specific project that was triggered by the ARM validator tool that we saw before, we can see here that the upstream says the ARM validator project asked to this project to please build and show me your results and show me if you are able to run under ARM architecture. This project has associated set of unit testing with it that if we double click here, we can see that the test written by the developers for this specific application, they were successful when they were running on ARM instance in Graviton2 AWS instance. So, okay, let's go back to our group where we have all the applications. And let's go back to our ARM validator project, the one that is triggering all the pipelines to observe if the applications are compatible with ARM architecture. So let's go back here. So from here, now let's choose a not so happy path and let's see what happened. So for example, this project, this .NET application, it failed at building. So if I click here, I can see what went wrong, why this job failed. It was, again, like the previous one, we were using the ARM architecture runner, but in this case, it didn't work. And what I can see here in the log is that there is a .NET not found here. So important thing to notice is that once we finished running all these projects in an automatic fashion for this group, what we are actually doing is that every time that one of these jobs failed, automatically they are opening an issue explaining the reason of why it failed. Like, for example, for these cases, the job that we were running was executing and building these applications under the ARM runner instance. So every time that the job failed, it automatically came here, like the previous one that we saw, the expenses one, and it will create an issue that will allow me to keep track of what's going on. So let's take a closer look at the collaboration capabilities that gets enabled once we can bring the conversation to the issue. Let's go back to this .NET expenses application that we saw that it failed at building. So let's double click in the issue, and from here, we're going to start moving towards the solution, bringing other people if needed or other developers that can contribute. The first thing that I will do as a developer is a quick search. What do I need to install, or what are the steps that I need to follow in order to execute a .NET application using ARM? Using my favorite search engine, the first result that I will get is that, as we can see here from the official documentation, that the .NET was made for x64 architecture, and that if I want to use it on ARM, I have to install .NET SDK manually. So what I can do from here is to take these links and bring them to the issue and start collaborating from there until finding the solution. All right, so now let's go back to our multi-project pipeline. We can see here we have this other job called consolidate, that what this will do is that once all the jobs are done, all the projects have been built, and I know which one succeeded or which one failed, this consolidate job is going to create a custom report for me that will give me a general vision or a general output in which I can start following up how many projects failed. So let's take a look at the consolidation report job, which is the last job in our multi-project pipeline. If we open the GitLab CI YAML file, we can see that this job has two stages. One, to collect the issues that were opened automatically by each one of the projects when they were executing their tests under the share runner using ARM. So this first step is collecting the issues and is creating for us a report in JSON. And then we just execute a custom script that is going to use the API of GitLab and is going to publish this result in the wiki of the project. So from here, what we can see is that every time we build the multi-project pipeline, we can get a simple report that can be customized for your needs, in which we can have the project ID and the reason or failure and some custom label that we can also define and a timestamp. So once we finish running the multi-project pipeline, this is a possible output that we can get. We can create this report, and from here we can start following up and bring other people to collaborate on this table and start measuring the progress and tracking the migration process from x86 to ARM. All right, let's recap what we have done so far. So we created a project that we call ARM Validator. Once we run this project, this will trigger a multi-project pipeline where we could see that we will have an output if the project was able to build or not. And once this multi-project pipeline finished, we can auto-generate a report where we can follow and track the progress of the projects that didn't build. Now let's assume that I am the actual person who wants to run this pipeline. It's as easy as just coming to the project, click on Run Pipeline, and here we can see that this will start the multi-project pipeline, testing each one of the projects. You are already familiar with the output of this. It's what we have been walking throughout this demo. So it's as simple as just opening the project and clicking on Run Pipeline. In this example, we have a group with 10 applications, but imagine that it could be 100 or more. And just with one simple click, you can start testing and creating a systematic and process-driven approach to learn how difficult it will be to migrate your applications from x86 to ARM.
Thanks, William. We appreciate you taking the time to explain that to everyone. So hopefully today what you took away from William's demo was leveraging CICD pipelines can automate your migration testing processes. 2, using a dedicated ARM runner simplifies that process in certifying your applications. And GitLab's single platform for DevOps can not only accelerate the time it takes your teams to test, but empowers your teams to collaborate during the refactoring process. If you'd like to explore GitLab a little bit more, please feel free to sign up for a free account on gitlab.com and try it out today. That's for our SaaS platform. And off of that same link, you could play with our self-managed version as well, if that's your preference. But again, thank you for taking the time to join us today. And again, I'm Pete Goldberg, Director of Alliances with GitLab. And William Arias spoke with you today as our Technical Marketing Manager. Please feel free to reach out to either of us if you have any additional questions about today's talk. And once again, thank you for attending.